This is hot topic number 10. We're going to talk a little bit about statistics, and we're going to discuss a lot of the values that the calculator will provide for you, a lot of the terms that you'll need to know, and we'll really spend a lot of time focusing on standard deviation on some of the last questions on the third page. But what we're going to do right now is we're going to take one of the examples. We're going to take question 6, which is on the back of the front page, and right now what I'm going to do is I'm going to put in one of the sets of numbers. So now I have a set of numbers in here from a different video, and what you want to do is you want to hit clear and enter when you highlight L1 and L2. That way you can clear out all the numbers at once. Now I'm going to, like I said, I'm going to put in team A, so I'm just going to put those numbers in. So I got, in this set there's 8 numbers. Okay. I'm just going to double check everything. Make sure I have them in the right order. I got 4, 8, 5, 12, which is good. 3, 9, 5, 2. So, sometimes in these questions you want to make sure you pay attention to what the question's talking about. So like in this case, it's talking about the runs scored for a baseball team, in case we need that information later for like some questions that deal with the context of the problem. So after you have one set of values in, if you were looking for mean, standard deviation, median, all those values, you go to stat and calc, and then you choose one variable stat and go to calculate. So some of the things I'm going to notice on this, I'm going to write some of these down on the paper just for your reference. So the first thing is that the mean on the calculator is the one that says X bar, and that in this case the mean for that set of numbers was 6. Standard deviation, which is something that you'll see a lot, which kind of looks like a O with a tail on it, then X next to it. That represents the standard deviation, and for this question that ends up equaling, I'm going to call this 3.16. We'll round it to the nearest 100. Now the next values we're going to look at tend to lend themselves to box and whisker plots. So we got the minimum, we call min x, which is the minimum value, which is 2. And then we have quartiles, Q1, which is 3.5, and then quartile 1 means 25% of the numbers. That's where you get to the 25th number. You will also see median. In this case, sometimes they refer to that as Q2, which would be halfway, 50%. You then have Q3, which is 8.5, which would represent 75%, and then the maximum x value, max x, would be 12. So that's the highest number that you get. Now, some of the other values that we're going to talk about finding, well, there's range, which would be max minus min. So that would be 12 minus 2, which would be 10. We'll also come across sometimes in the test, which is called the interquartile range, which is Q3 minus Q1. So that'd be 8.5 minus, space, I'll rewrite it down below. 8.5 minus 3.5, which would be 5. And the last one that we don't really see, which would be mode. The mode would be a number that's most often occurring. So if I looked at my list right here, I noticed that I had 2 5s. So the mode in this case would be 5. Okay. Those pretty much go through all the values that you're going to see or come across when you have to use one variable stat. So like for this one right here, this one's asking for a comparison between the means and the standard deviation. So for this one, I'm going to need the mean value, which was 6, and the standard deviation, which in this case was 3.16. So now we're going to go to the last page. We're going to look at 9 on the bottom of the last page. And this one talks about the differences between mean and standard deviation. So the whole premise of this is the idea of a normal curve, and the mean value is the number that would be your average. And standard deviation, going left or going right, standard deviation would be based on the spread of the numbers. So when that comes down to it, the higher the standard deviation, the more spread out your numbers are. So they're asking which school has a greater consistency in the scores. So what that means is the mean doesn't really matter. The mean is just the average. The standard deviation tells us the consistency. So in this case, the smaller the standard deviation of x, that would mean the scores are more consistent. So if you take something like, for example, if you take a set of numbers for a soccer team, usually soccer is a low-scoring sport. Let's say the numbers were 1, 2, 1, 0, 3, 2. But then you take the numbers for a basketball team that scored. Maybe it's a high school basketball team. You have 52, 48, 61, 73, 37. Okay. The one that's going to have the higher standard deviation would be the basketball numbers because the numbers are more spread out. Whereas if you take a soccer team that rarely scores goals that much, those are going to have a smaller standard deviation. Those scores are more consistent. They end up being around that mean value. So I hope that helped. And if you're in class, please let me know if you have any questions on the section.